Okay, so the other thing I wanted to do today, if there are no other questions on Kepler's laws, is I wanted to discuss one of the activities that we're going to be using or going to be doing that looks at the motion of the planets. Now that we know how motions work, because Kepler's laws applies to the solar system, it applies to our Earth and Moon, we want to see if we can use observations to figure out the motions of the planets. All right, so this is the phases of the Moon activity, and what we're going to do is use this to figure out the motion of the Earth and the Moon and the Sun in our solar system, and these motions are used by Kepler's law. You have up here you have the observations of what the moon looks like throughout the entire lunar cycle. And you've probably seen the moon look like this. You go outside and you see what's called a waning crescent moon or waxing crescent moon, or you don't see any moon at all. We call that a new moon. You've seen first quarter waxing full, and this is called a gibbous moon when it's between first quarter and full. Waning gibbous, third quarter, waning crescent, and then it reverts back to here and goes through it again. So that's the lunar cycle. That's what happens when you look out and see the moon through the course of the month. And this is the order in which you would see those phases of the moon. And so your job with this activity is to work out how the moon actually moves around the Earth. Now, you know that the moon goes around the Earth, but from the phases you can tell the direction that it goes around the Earth, and also you can measure, if you measure the time between phases, how long it takes to go around the Earth. So your job, and this is you can do this on your own. It's easier if you have a couple people to help you, but you can do this on your own. What you're going to do is build a model of your Earth-Moon system. You can pretend you're the Earth. You can hold out a little ball or something like that to pretend it's the moon, and then you can put the sun as some object around, some lamp in your house or something like that. And when you take this ball and move it around, you're going to imagine that you're seeing the lit part of the ball as you go around, right? So if I've got a lamp right here. Everybody sees my lamp, that's my sun, so the sun is off to my right. If I hold out my hand like this, right, the moon is directly in front of me, and I'm looking directly at the moon, I can see that from my perspective the right-hand side of the moon is lit. And if the right-hand side of the moon is lit from my perspective on the Earth, I can go up here and discover that that is the first quarter, right, because that's the right-hand side of the moon is lit. I come down here to this little drawing, and this is us looking down on the solar system, looking down on the North Pole of the Earth. I find the one that says first quarter, and I draw it. So I'll go ahead and do that. So I find the one that says first quarter, and I draw it. And because my sun was off to my right, I'm the Earth, and I was holding my hand out in front of me like this, looking down on the top of my head, I can see that this is where the first quarter moon is. Okay. So then I want to do another one. Well, the other easy one to do is the full moon. So if I have this, again, the sun is that way, and if I'm looking at it like this, here's my full moon right out in front of me. If I don't stand in the way of the light, I see that the entire moon is illuminated, so I know that's how I know it's full. Right? And then I can see that it's directly opposite of the sun. So I go again up to my observations here and I see the full moon. And I go down here to find out where it says full, and I draw that. So I know that the full was completely opposite the sun, like this. And then you can do that for third quarter, you can do that for crescent, waxing crescent, waning crescent, and fill in this whole map. And when you do that, because you know that this is the order of the phases, you'll be able to see exactly how the moon goes around the Earth. So that's the first part of this activity. The second part is using what you've just learned to figure out some things about, answer some of these questions about these observations that you made, but then also doing some things about what the Earth looks like, right, from these different models. So in this case, for example, I've got a view from the Earth which shows the moon, right? And I've got to figure out where the moon is up here. So you can match that back to your previous page, or you can do the dance again, do the model, and see where it is. For this one, I've got the Earth-Moon system, and I need to figure out what it looks like from the Earth, right? And same thing here. And then we have you go to Mars and do something similar. And then the really fun one is once you can see where the phases of the moon are and where it is in the sky, you can tell things like the time, right? You can tell the time from where you happen to be on the Earth and where the moon happens to be. So for this particular example right here, we have the phase here. You can probably tell me what the phase is. The phase is a full phase, because I knew that from back here. So this is full, so I can write down the phase here is full. And I can tell that the sun is opposite the moon. So wherever I'm talking about, the moon has to be on one side, the sun has to be on the other. And I know that the Earth, if I'm looking down on north, the Earth rotates counterclockwise, like that. So if I'm here and I'm rotating counterclockwise and I imagine my horizon sticking out like this, then that means that the sun, since I'm rotating this way, is on the western horizon and the moon is on the eastern horizon, and that means that the time is around 6 p.m. because it has to be at sunset. So if you know where the phase of the moon is, if you know what the phase of the moon is, and you know where the moon is relative to the sun, you can figure out what time it is, which is pretty handy if you're ever outside without a watch and you want to figure out what time it is. Okay, so this is the activity I'd like you to do for next Tuesday, I think is when we're going to have that. And you can email me any questions that you might have.